So this is chapter 3.5, number 6. Problem with this question is that the question itself is kind of complicated. And it's a good precursor to what's coming up in chapter 3.6. So, number 6, use patty paper and a straight edge or a compass and straight edge. Construct a parallelogram gram with RG and RA as two consecutive sides and ML as the distance between RG and so I'm just going to sketch that first. So RG is one side, and then RA is another side that's consecutive. So there's RG and RA. And ML is the distance between RG and AM. So we've got another vertex up here, which is M. ML. Distance between RG and AM. So the distance between these two sides is ML. So with the way I've sketched this, I need to come up with L over there. Now could I construct this parallelogram differently so that I would have ML falling inside parallelogram? The distance between these two sides has to be on a perpendicular. If I took this parallelogram and flipped it this way, so RG, M, A, that's a lovely picture, isn't it? And then ML. So I could do either one of those. This is parallel to that, and that's parallel to that. Let me make a better sketch. Arguably not better. Okay. So the line segments that I'm given are RG, this one here, and RA, this one here. Now, are these opposite sides of the parallelogram going to be congruent? Can I say that?
Why is it so loud?
I think it's windy outside.
It's never. Yeah, it is everything. I got, but my room is on the third floor because of noise. I think it has something to do with like the position. Are you still recording? Is it recording?
Yeah, it is actually. Isn't that lovely? So I'm going to start with point R because R, at least it's in common between RG and RA. And I'm just going to start copying segments from the textbook. They want to be recorded, but then they forget. So I'm going to put RG on this ray. So there's G. And then I can put RA. Now, I don't really know what angle I'm going to have at R, so I can't make another ray for it, but I can make a locus of all the places where it could be. Gosh, I hope that doesn't end up going off the page. I'm a little worried about that. You know what? This is going to be a completely botched construction because I'm going to start over. I think the recording of number 6 is just a complete failure.
Can you put it up anyway? Yeah. Just for fun.
Just for kicks.
So there's RG, and remind myself again where I'm going with this thing. And L is going to be over there. And A is anywhere that's this distance away from R. Actually, M is anything that's this distance away from G, too. So I need to come up with the side that's opposite RG. The thing I know about it, since it's a parallelogram, is that they're parallel. And I know how far away it is. It's LM away from RG. So distance between parallel lines has to be measured on a perpendicular. So if I create or construct a perpendicular from this side, I'd be able to figure out how far apart that opposite side is. So I could just pick a point over here. And construct its perpendicular. Isn't this exciting? So there's our perpendicular, and I know it's LM away. So I copy LM up here. So that point here has to be on the other side. And if I want to make it parallel, I could do the alternate interior angles copy, Kyle. Or I could do the corresponding angles copy, or I could construct a perpendicular through this point. I'll construct a perpendicular through it. Don't worry, number 10 is more fun. All right, look at this. I went and I constructed a perpendicular. I made it the right distance away to be the opposite side. And then I constructed a perpendicular to this line through this point. Now I have a line that's parallel to the original RG. It's the right distance away. And these two arcs that I drew that are the right distance away to be points M and A. So A is somewhere on here and M is on here somewhere. Where those two arcs cross that parallel line, that has to be where point A is and M. So that actually completes your parallelogram. Now the last thing that I had, so that's the parallelogram. That's Graham. I haven't actually fully constructed ML, so ML would start at this point M, and it would be perpendicular to the side, so I just do another perpendicular construction. Page is getting littered with stuff, right? So there we've got the final piece. This is perpendicular. That's M, that's L. And the distance of that ML should match the distance in the book for ML, which you can't see because I'm going off the camera, and it looks pretty good. So yeah, that took 10 minutes to do. It's a long problem. Takes a while to get through it. There weren't a lot of questions in the homework. They weren't all that bad. Any questions?